this is the a-BBQ-chef. It's an automatic barbecue that raises and lowers your meat based on the temperature of your barbecue. Try to keep the meat at a constant temperature, and it will also flip your meat for you. It features a temperature sensor to get the temperature of the grate and the temperature that the meat will be sitting at. And also it features switches to determine the location and prevent damage to the mechanism. So this barbecue is designed to be built with just hand tools so that anyone could make one in their own backyard or in their house if they wanted to. So most of it's made out of wood in the areas that are away from the heat and safe to be made of wood. The rest of it is made with very common materials. This is some electrical conduit tubing, very common size. And this is some very common bar stock. So pretty much all of it can be made with drills and saws, with the exception of this bar that needs to be welded, but that's not. Okay, so due to the fact that it's been made with hand tools, all of the measurements aren't exactly accurate and things are a tiny bit off. So to account for that, we have these guide wires that help add rigidity and stability to the system and make sure these bars are straight so that the grate can move smoothly up and down the bars here. So here we have the temperature sensor attached to this copper rod that allows us to get the temperature of the barbecue grate, and its wires are insulated by this ceramic tile with insulating little black pieces here also.
Here we have our control board with all the buttons and LEDs showing all states of operation. We have here a start button to press it whenever you want to cook your meat. We have the stop button, some kind of emergency button. Whenever you want to stop the procedure, just press it and the barbecue goes back to its safe position. We have two potentiometers, one to set the cook time, so the time it actually burns the crust on the meat, and the second one to set its broil time to make a smooth meat. We have these two LEDs indicating the motors working. So if the first LED indicating so the lift motor is working, the second LED to indicate the turn motor is working. Here we have the ready LED. Whenever the barbecue is ready to get its meat applied or just to start, the LED is blinking. Then we have the meat LED that indicates the barbecue is now ready to apply the meat. And we have the arrow LED that lights up as soon as someone presses the stop button. Here we have the whole controlling setup. We have an Arduino Uno controlling the whole barbecue. And we have a motor driver board that can control up to 2 DC motors or 1 stepper motor, but we are using the 2 DC motors. Everything works on 12 volts, so the whole setup can be driven by an auto battery. So here we get the mechanism to drive down and up the grate. It's basically a DC motor with a coupler to a rod, and this rod just spins up 2 wires that are connected to our grate. To set a limit to the highest and lowest position, we have a end stop on this side. It's a snap action switch that gets triggered as soon as this grate rail hits the switch. And we also have one on the lower position, same switch. As soon as it gets hit, the motor circuit gets interrupted. You can here see how it's working if the grate is driving down. The motor is unspinning the wires and letting down the grate. The lower end stop would be reached. Stop. We can see here, as soon as the rail thing hits the tactical switch, it immediately stops the motor. So we have here a second motor to turn our grate. It's also coupled with a coupler to the actual rod that holds our grate. The whole mechanism has also 2 end stops, one on this side indicating the end stop on the left side, and one up here indicating the end stop on the right side. If you want to turn the grate, goes around automatically, and as soon as it hits the other end stop, the motor circuit is opened and nothing else can happen. As soon as the system starts up, the motor drives up the grate until a safe position on the top of the barbecue.
So the system's now at the safe point and it's ready to start the process.
The readiness is indicated by the blinking ready LED. So to start the barbecue process, we press the start button and the motor starts to lower the grate to find the right temperature for the meat. The right temperature range is reached, and it indicates this by the blinking meat LED, so the barbecue is now ready to take the meat.
So for this demonstration, we're not going to use any meat. It's just a demonstration, but now would be the time that you would insert the meat onto the barbecue.
After you apply the meat to the grate, just press the start button again, and it cooks the meat for the adjusted time, so in this case 1 minute. During this 1 minute, the barbecue also adjusts its height to always keep the right temperature.
And since it's a little breezy out, it'll most likely be going up and down a little bit to try to keep that temperature.
After 1 minute is reached, the barbecue turns the grate automatically and burns the other side. Also for 1 minute. After 1 minute is reached, the barbecue turns back the grate, so the temperature sensor is on the lower side again, and drives up, so the temperature lowers a little bit and the meat can broil the rest of the time in a lower temperature. Now we reach the point of lower temperature and stay at this position for the Senate for all time. And also in this position, barbecue just as tight to keep the right temperature. Now the grate has reached its final position. Meat is ready to be taken off the barbecue.
So during this project we learned a lot, and one of the biggest things we learned about was dealing with high temperatures. And we had some problems with common fabrication techniques not working with high temperatures. And that includes things like we wanted to solder our temperature sensor to wires. And the temperatures we were working with on the barbecue were a little bit higher than the temperature that solder starts to melt, so we had to come up with other methods to deal with that. We also had to deal with some stuff like keeping the wires protected. The insulation would melt, and so high temperatures definitely brought its fair share of problems, but we learned a lot about how to deal with those temperatures.
Another thing we learned about is that basically everything can be improvised by really simple and basic tools. So we didn't have any access to a workshop and have to do everything with a drill and a saw. And it probably worked everything. So as an engineer you always have to improvise, and you probably can improvise nearly everything with basic stuff.
Yeah, and in addition to that, we also learned about how to build cheap mechanisms using common materials such as the metal or 2x4s and things like that. So we learned how to kind of make our mechanism off of those and still have a nicely functioning mechanism.
Another important thing is if you do things improvising with basic tools, tolerances are really important. Never think you can work as accurate as with a press drill. If you only have a hand drill, make sure your holes are big enough.
We also learned a lot about choosing our materials wisely and choosing the source that we buy the materials from. So in one case, one of our motors we ordered from Amazon was a little bit cheap quality, and one of the bolts broke off of it, and so that was something we probably should have chosen a different source or looked into it more. And then also sometimes you can get away with using cheap materials in the right places. So in the case of the wires that lift our mechanism, we were able to use some really cheap wire, just electrical wire, as it was able to hold the weight, but it was also very cheap.
In the end of our project, we learned a lot about CAD programs and the Arduino and how to work with the Arduino in a professional way. So how to achieve really complex tasks with a simple microcontroller like the Arduino, and how powerful all these programs and tools are. So this was really helpful.
And we also learned that you'll always run into more problems than you think you will, and definitely in places that you would never consider run into problems often. So we had a few setbacks that put us back, but it's how you deal with those things, and we learned a lot of how to deal with problems and solve them to make a working mechanism in the end.
Well, the project itself now is not really perfect. It's only a prototype, so it also can be improved. And we figured out some things that really have to be improved and can be improved easily. So the first thing is the whole wiring setup. So for now we had a breadboard where we connect all the wires. That takes a lot of time to set it up and to wire it everything, and it's a big source of errors. If you wire just one simple cable wrong, the whole system won't work anymore. So we figured out we can just make a big connector with a lot of pins, so wiring will be way faster and without any errors anymore.
Yeah. We also would like to improve the mechanism that holds the cooking grate closed. At the moment, it's a little bit of not the most practical solution. So we're using some sort of clips at the moment, but in the future we'd like to use some sort of latch system that will be easy and quick to use. Yeah, and just be much more simple and effective.
Another nice improvement would be a visual communication with the user. So we thought about something like a GUI program that displays the temperature and the state of the overall system. So whenever you use it, you can see what temperature is your temperature sensor right at the moment, in what state is your grate right at the moment. So you can easily see if something goes wrong, or if you just want to check up how far is your meat so far. Yeah, you can just take a look and you'll see it. So right at the moment you have to guess.
Yeah. And then we'd also like to look into maybe making some modifications to our sensor or choosing a different sensor. And mainly we'd like it so that the temperature reading can be a little bit more fast. Get a better, more accurate temperature reading more quickly, because currently it's attached to a large piece of copper wire, and while copper is able to change its temperature fairly quickly, it is a large piece of copper wire, so it does take a little bit longer to respond to temperature changes at the sensor. So
another nice thing to have would be a second sensor inside the meat. So we don't have to guess if the meat is ready or not, but we can actually measure the core temperature of our meat and say, okay, if a certain temperature is reached, the meat is definitely ready and the grate can drive up again. So this will improve the quality of the outcome of our product.
yeah, and also just one sort of small thing is we'd like to maybe encapsulate the motors or cover them in some way so that they could be more water resistant and just more resistant to the elements. So if you wanted to use this in like a backyard kind of scenario, you could leave it outside and not have to worry as much about getting damaged.
The last thing we thought about could be improved is the lifting speed. So if you may have seen in the video, our grate is driving up and down really slow. That's due to the fact we sized the motor really strong, but therefore also really slow, just to make sure it will work. So when we found out it's really strong, we can use a weaker motor or just a gear head with less gear, so it will spin up the wiring faster and drive the grate faster up and down. Yeah, so far that's everything we could think about. Thank you for watching our video.